Hello, everyone. I would like to introduce our IPMI 2021 paper titled with Future Frame Prediction for Robot-Assisted Surgery. Medical imaging and surgery jointly contribute to a common treatment procedure. Traditional surgeries are performed by opening the body to gain visual access to the targeted areas, which are entirely invasive procedures. With the development of computer-assisted intervention, the invasive of surgeries could be lowered, and the relationship between computer-assisted intervention and medical imaging is more and more close. Computer-assisted intervention is essential for modern operating rooms to promote surgical therapy and structural repair. The typical applications of a computer-assisted intervention include context-aware system, robot-assisted surgery, and surgeon training. The main goal of context-aware systems is to ensure operating room situation awareness and assist the surgeons in preventing medical errors. Most of these tasks only focus on the events that are happening right now, while leave the future awareness unconsidered. Although some high-level future information, such as remaining time, scheduling, has been generated, the detailed future sign prediction in certain scenarios is rarely studied. The definition of future frame prediction is that given some observed future frames, we aim to generate the following frames in a pixel space. The difference between surgical videos and general videos are obvious. First, surgical videos generally have longer duration without clear boundaries among different phases. The movements of surgical tools have clear goals rather than repeated patterns. Last, the interactions of different robotic arms are complicated and they have limited interclass variance because the signs are generally very similar. Surgical operations are generally hard to describe and hard to learn, and the future SEM prediction provides an image-guided navigation beyond the semantic descriptions. Although offline performance is higher than online workflow recognition, generate future sign could facilitate the online recognition with anticipated future tendencies, which falls in a kind of human-like manner. In this work, they propose a framework that uses future information as a guidance to boost the current recognition performance, which implies that the future information is actually very important for the current recognition. Also, knowing the detailed future sign is a higher level of interpretation in surgical videos, and knowing which operating phase is performing is not enough for the next generation healthcare systems to conduct automatic surgery. For video prediction, current works mainly fall into two categories. Deterministic methods only assume one future outcomes and might generate blurred results due to multiple future possibilities. As a typical method considering stochasticity, variation autoencoder model assumes that xt is generated by some random process involving its previous frame xt minus 1 and a latent variable zt. This process is denoted using a conditional distribution which can be realized via LSTM. However, it does not consider the domain knowledge in dual-arm surgical videos. In this paper, we propose a ternary prior guided variation autoencoder for robot-assisted surgical videos. Our framework is first composed of a decomposed video encoding network. We use VGGNet and LSTM to extract spatial temporal features from surgical videos, and we use the posterior latent variables of content and motion and timestamp t to capture the dynamics in surgical videos to facilitate the reconstruction of the original frame xt, conditioning on observed frames. Note that the motion information here is denoted using the direct difference between neighboring frames. And the prior distributions from content and motion and timestamp t-1 are optimized to fit the posterior distributions and timestamp t because no more posterior information is available during testing. Thus, using the distribution representation, we could model the diversity possibilities in surgical videos to indicate the different preference of a surgeon to operate the surgical tools. Next, we introduce the ternary latent variable. Anticipating the future development based on some inherent information can definitely reduce the uncertainty. Thus, we propose a ternary latent variable to constrain the latent space of our model for better future generation. Besides the designed content and the motion prior, we also include the prior from class label information. Here, we directly use a ground truth label to get our generation. Even if there are no ground truth labels, they could be predicted since the gesture recognition problem has been well solved with a relatively high accuracy. A possible scenario in surgical training is that we know which operation to do, but we do not how to do. With different prior, our method has better interpretability than black box methods. Also, our method does not entangle the recognition of observed frames with future frame generation, while these black box methods only entangle these two tasks. Then, by referring to ZT, that is a ternary latent variable, the next frame could be generated using an LSTM and a decoder. Our model is trained by maximizing the variational lower bound, and the likelihood term is replaced with the L1 reconstruction loss. During inference, the expectations of the prior distribution without sampling are used to produce the most likely prediction. Also, choosing the best generation after sampling several times is not practical for online prediction scenarios. We use the suturing task of the jigsaw dataset to validate our method. The video frames are resized to 64 times 64, We choose adequate video clips from G2, G3, G4, and G6 classes, and the training set of our method is about 400, and the testing set contains about 100 sequences. We employ three metrics to evaluate the performance of different methods. VGG cosine similarity uses the output vector of the last fully connected layer of a pre-trained VGG neural network. PSNR generally indicates the quality of reconstruction, while SSAM is a method for measuring the perceived quality. Here is the qualitative results. Generations from MCNets are sharp for initial time steps, but the results rapidly distort in later time steps. Here SVGLP star is the variant of SVGLP, which is trained using L1 loss. We can see that SVGLP and SVGLP star tend to predict static images of the indicated gesture, which implies that the two misunderstand the purpose of the current gesture. MLVAE is a variant of our method that only uses prior from motion and the class information, and it tends to lose the movements of the left hand and confirms the importance of the content prior information. Capturing the movements of two arms, our model gives the closest prediction towards the ground truth. Here are more qualitative results. Here is the quantitative results. Concerning VGG cosine similarity, MCNet shows the worst curve because of the lowest generation quality, while other methods behave similarly. The reason might be that the frames with good quality are similar to each other on a perceptual level. For PSNR and SSAM, all methods maintain a relatively high level at the beginning, while deteriorates as going further into the future. Interestingly, MCNet demonstrates a poor generation capacity that its performance curves on three metrics deteriorates faster after going through the dotted lines, which indicate the generalization capacity of each method. MLVE also expects superior outcomes than the other compared methods, which verifies the effectiveness of the proposed motion encoder and the class prior. Our full model exhibits a stronger capacity to retain image quality in longer time span. The two arms of the Da Vinci robot cooperate mutually to achieve a certain task. Thus, the movements are highly entangled, which makes the prediction very challenging. Without enough prior information, the predicted frames might lead to unreasonable outcomes due to the loss of temporal consistency. We can see that the result of SVGLP tend to lose the left arm in later generations. Owing to more complete guidance, that is a ternary prior, our methods predicts the movements of the two arms successfully while shows crisp outcomes, which verifies our assumption that additional references help for prediction of the dual-arm movement. Here I want to briefly introduce our following work. We employ key points to predict surgical videos, which is a more explainable decomposition style for the fore and the background parts. Since key points are a kind of low-dimensional data, the storage consumption is much lower, and the higher resolution results could be achieved. It is interesting to note that the left arm enjoys more key points, which might indicate that the movements of the left arm are more versatile than the other one. These results are achieved via an unsupervised learning framework. Maybe much better results will be obtained using labeled key points. In this work, we present a novel method based on VAE for conditional robotic video prediction, which is the first work for dual-arm robots. The suggested model employs learned and inherent prior information as guidance to help generate future scenes conditioned on the preserved frame. Our method outperforms the compared methods on the challenging dual-arm robotic surgical video dataset. Our work might inspire future applications in surgical video interpretation, virtual and augmented reality, and image-guided surgical automation. Thanks.